Hi, everybody, and welcome to another episode of the Risk Matrix.
The Risk Matrix Roll Tide football season is underway. Thank goodness it's back. And I'm glad to be back, my friend Dr. Martin, here on the Risk Matrix today, talking industrial hygiene.
Oh, no. Oh, no.
Everybody just turned off.
That's right. Everybody just said, they either perked up and said maybe they're going to give us some tips, or they turned it off because they don't want to hear anything about industrial hygiene because it is a black box that nobody seems to kind of understand, except for like the CIH wonks or people who really have done it for a career. But before we do that, before we get into that, what our path is going to be in this conversation. James, why don't you give us a little word from our sponsor about a really great opportunity?
Well, this episode is sponsored by the National Association of Safety Professionals, but really what we're promoting and talking about, Dr. Martin, is this great opportunity that's going to happen in October. Veriforce has teamed up with the National Association of Safety Professionals to offer the Certified Safety Manager course in Houston, Texas, at the Veriforce headquarters beginning in October 16th. So this course, like I've said before, isn't just about slides and lectures and theory. Man, it's hands-on, it's interactive, it's tailored to meet the needs of all participants. It's taught by some of the best instructors in this country, real safety professionals just like you. So if you're starting your career or you're a seasoned veteran, doesn't matter. This course ensures that everyone gets the knowledge they need to excel in whatever their journey is in their safety management role. So registration is still happening. It's happening right now. And I promise you this class is filling up fast. So visit naspweb.com/classroom and look for the October 16th CSM, the Woodlands course. And Veriforce clients can receive up to a $300 discount at registration. So register now.
Well, don't leave right away because we're going to talk about something. But remember that at the end of this podcast, that you should really go and take a look at that. I agree with James. There's some great instructors, some great baseline, and even advanced material for people to use in their safety careers. So thanks for that, James. So you started this show with industrial hygiene. Even as a certified industrial hygienist, I even flinch sometime when we start talking to clients about their industrial hygiene needs. And part of it is because people are afraid of it. I don't think that there are many things.
You're a CSP, okay. I'm a CSP. We're all CSPs, MSPs, all these different designations. I know there's a fear because when I talk to people that don't hold these designations or certifications yet, the number one question that is asked is how much math is on the test. And when they say math, what they mean is how much of the industrial hygiene concepts is on the test, because if I was good at math, I'd be doing something other than being a safety professional. And this creates all this anxiety and fear, and sometimes people perform poorly on the examinations because of that. And if we're that afraid of it, at least in the audits I've been associated with here the last few years, people just ignore it. They ignore their responsibilities under industrial hygiene. And so I think maybe we should begin with Dr. Martin talking about what is industrial hygiene. Let's demystify it.
So I mean, in a practical sense, there are only a few things that most safety professionals now need to be aware of, right? And they're in the OSHA regulations. And we talked about this before we got on the show, right? There's regulations for lead. There's specific regulations for asbestos. There's specific regulations for silica. There's respiratory programs, noise, and probably a few others. But these are the ones that everybody has to deal with. There is some good material on the OSHA websites, right? And it has been somewhat demystified, but you have to remember that they put it in the least common denominator. They want everybody to be able to understand how to use these programs, implement them, and do the measurements that they need to do in order to keep people safe. Now, before I let you loose on this, I'm going to say this. The fear of math, right? There is some math as an industrial hygienist that I do, okay? It's necessary. It has to be done. However, our technology has come a very long way in as many years as OSHA probably put some of these standards in effect, with the exception of silica, which has been a more recent advancement. But there are meters that do the things that we need them to do for the calculations, if they're used correctly, if they're calibrated, and all those things. There are also labs that just do industrial hygiene that do all those things for you, right? They do the pump jockey, they calibrate, you can do your own sampling or not. They tell you which media to use. So there's, in my mind, there's really no need to be afraid of industrial hygiene. And if you really do have a fear, there are people out there that, like myself, that you can call upon to either get an assist as a consultant or to do it for you. But I will say that, what is industrial hygiene for the basic safety professional? It's what's in the OSHA regulations, and you key on the hazards that are in your workforce, which are a lot of those that I mentioned.
I like to think of it this way. Industrial hygienists do a lot of the same things that we as general practitioners in occupational safety and health do, where they're identifying hazards, determining risk and exposure, and protecting workers, right? But you're using a more of a scientific method and approach to that, and helping us determine what the proper controls are, particularly around chemical exposure. And we'll talk about some of those in a moment. But my experience with industrial hygiene in helping contractors is they try to abrogate their responsibility sometime to the group that hired them. They say, well, our hiring client should tell us if it's a noisy area. Our hiring client should tell us if we need a silica plant. Our hiring client should tell us if we need, some other type of exposure, chemical exposure. Let's say, for example, lead or asbestos. And maybe they should, but at the end of the day, you're still responsible for taking care of your workers. So what I'd like to do is kind of back up to some of these standards that require industrial hygiene and talk about resources people can get and just demystify this thing. For example, number one portion, I guess, audit finding, I would say, related to hearing conservation is you have a written program. You may give out some type of hearing protection, but you're not doing baselines, you're not doing annuals, and you may not have to, but because you didn't do any noise surveying, you don't know what exposures are. So how can companies go about doing proper noise evaluations and exposure evaluations?
So to answer that question, listen, I'm a consultant, right? So you're asking an industrial hygiene consultant, how do they go about it, right? I say hire me, but really, you need to really dive into the standards and go to some of the websites that have these papers and fact sheets and things of that nature. I would say NIOSH CDC is an excellent place to go. They actually outline all of the things that you need for example, hearing conservation. They give you example programs. They tell you how to evaluate things. And honestly, at some point you will have to hire, maybe not an industrial hygienist, but you might have to hire a mobile van that comes in to does the hearing conservation baselines and the yearlies, right? You may have to consult with an occupational health clinic, right? An occupational health clinic has these resources available. And if you know the hazards, right, and you've done the work, and what I'm saying here is that you actually have to do the work, and James has said this too, and I will say, James, no matter what we talk about, you always bring it back to the hazard assessment. Always, right? As a baseline, I don't care who you are or who you're working for, you are responsible for your employees to do that hazard assessment, right? And part of the hazard assessment, taking hearing conservation, is taking measurements around your area in accordance with what OSHA has in their standards. We know what noise is, right? But is there a problem? You don't know until you measure, okay? Equipment manufacturers, also very good resource for how their equipment works. A lot of them have fact sheets that are not related to their equipment, but they're related to all the things that you need to go with their equipment. So, I mean, these are good resources.
So let me ask you this from a practical standpoint. When I'm thinking about and trying to determine whether or not my workers are exposed in a hearing conservation plan to the action level of 85 dBA TWA, right? Is me going out there and downloading like a sound meter app and standing in the middle of the room and holding my iPhone up, is that going to be sufficient? I mean, what do we need to do here?
Okay, you brought up a really good thing that I brought up in many of the courses that I teach, that there are a lot of good apps for the phone, right? But these are screening tools, okay? Most of the apps on your phone are screening tools. If you want to do it right, you need to use a calibrated instrument that is taking the measurements that you need in the weighted range for hearing, in order to form that opinion that you need to go a little bit further, or your program needs to go a little bit further. But what I will say about those apps are, look for the apps and use the apps to screen, do I have a problem? Might I have a problem? And where are my problem spots? So then when you do hire somebody, or you go about using the calibrated instrument and enhancing your program, that you're focusing on the right areas. Okay, this goes back to hazard assessment, right? If you have oil and gas manufacturing plant, or a refinery, or a construction site, right? You know what's making noise, okay? And you know you can rank them, right? I mean, we all hear, unless you have some kind of a hearing deficit to begin with, we can all hear where the noise is louder. So start with your loud and work your way back and see where you kind of have that cutoff on the areas that you need to address.
So could I use a mobile app to determine, like right at the source, if the source is 72 dBA, do I need to worry about a hearing conservation plan? If workers are not working right next to it, I mean, it's way below the action level. Could I use a non-calibrated instrument to give me an idea of whether
Yes,
or not I need to do other stuff?
that's exactly what I'm saying is, these apps can do a lot of things. They, there are apps for heat stress, and there are apps for hearing, and there are apps that have the NIOSH guide on it, right?
Right.
I mean, I have all these things on my phone. You can get the ERG guide for emergency response. If you're a safety professional and you want things at your fingertips, they are there, and you need to just take a look, right? There are a lot of hearing apps. There are a ton of them.
Okay, let's move on to like chemical exposures and we'll deal with lead and asbestos and silica because they have their own standard. But basically, what I'm talking about is chemical exposures that you find in the Z tables, like 1910, 1000 Z table 2, what you can safely be exposed to over 8 hours a day over a 40-hour week. Now, my roots are in the chemical processing, oil and gas industry, construction, maritime industries, but this applies to all industries. This is what OSHA says you can be safely exposed to over 8 hours a day over a 40-hour week. Now, we're going to have an extensive conversation about this, but let's start with the validity of the table. Okay, this table was made when? What are the origins of the Z table?
Well, I mean, most of the standards in the Z table and most of the things in the OSHA standards were promulgated in the 70s and 80s, when we were just getting started putting that standard set together, right? If you look more recently in the late 90s, 2000s, 2010, and now, getting a standard or changing a standard within the OSHA regulations is almost non-existent, right? Unless it's something like, it's impossible, right? It's impossible for a lot of reasons, and we can go in that on another show. There are lobbyists, there are special interest groups, there are political groups. There's all kinds of things that interfere, right? And it's a really long process if you look it up through OSHA, how things are promulgated. So a lot of these standards are old. They're based on old research. The ones that have been updated are ones that people have taken a special interest in because they're carcinogenic, or Maybe that's just their special research topic. And some of them never get researched again. Okay. So, you know, when I look at the OSHA PELs, I look at them as, that's the least that you need to comply with, but I would not say in most cases that it's protective of your workers, right? And so, you know, I would direct people to go to the ACGIH TLV guide, to go to the NIOSH RELs and compare some of these standards, because many of them are much more stringent, which, and we can have this debate on another show, which is a best practice to, you know, to protect your workers, right?
Well,
So
I'll just put a parentheses here and tell you what James's opinion is. You know, when I'm looking at and there's often a lot of differences between what the American Conference of Governmental Industrial Hygienists puts out in their TLV guide and what NIOSH puts out in its RELs, recommended exposure limits. And I'd like for you to talk just a moment about the two, because sometimes they can be varying. Like ACGIH seems to be extremely more conservative about employee exposure than NIOSH is. Could you explain why that is?
well, NIOSH is connected to the federal government, and ACGIH is not, as I understand that, right? But they're both research organizations, and in any research, okay, if you want to know why is there a difference, you have to look at the research that they relied upon, right? And this can get to be really sticky, right? Because maybe NIOSH has thrown something out that ACGIH has kept within their body of research that influences what they have as a standard. A lot of this is common sense. I think what we need to focus on is the PELs are least restrictive. They are old. Best practice is what, and this, again, this is a personal statement here, James. This is not a Veriforce or a risk matrix statement at all. In my mind, we have to do the best we can for our workers, and the best would be the most stringent. Okay.
I'm gonna disagree. I'm gonna disagree.
My opinion.
Okay.
Bring it.
Give me an example. And ordinarily, I'd say that I would agree with that statement. I think the main difference between NIOSH's recommended exposure limits and ACGIH is NIOSH also considers technology and economic feasibility. I'll give you an example of dealing with H2S, something we deal with all the time. OSHA, believe it or not, in the general industry standard, 1910-1000 Z Table 2 does not have a PEL, a permissible exposure limit for H2S. They have an ACC sealing concentration of 20 parts per million, but no PEL. In the construction standard, they do have a PEL, and it's 10 parts per million, right? Now, NIOSH's recommended exposure limit is 10 parts per million, and ACGIH's is 1 parts per million. Now, if we went with the most restrictive standard in that case, I don't have a reading instrument that can even reliably tell the difference between what 1 part per million is. We just can't read it, right? So knowing that, and knowing that the effects on the body between 1 and 10, you know, are not that much more significant, I can read at 10 parts per million. I can have a reading instrument that does that. I don't have to put everybody in the truck under air because they get out, you know, because 1 part per million H2S might be in the air that we breathe on a regular basis. So I like to think when I am, but I'm not a certified industrial hygienist. I would like your opinion to respond to this, though.
Oh, I'm going to respond. I'm going to respond. You go ahead.
I lean upon, I hear you. I like to lean upon NIOSH.
All right.
Okay.
All right.
Because they consider economic feasibility and technology in making their recommendations.
So let me revise my statement to you. It depends. Okay. and you gave me, I used to play softball and I wasn't a very good hitter, but you gave me a softball I can hit, right? And you gave me a softball I can hit because we're talking about the H2S standard. And as we know, we have a working group that works on the H2S best practices standard. What is it?
Yeah, Z390. I'm on that committee.
You're on that committee.
I
Okay,
am.
so
I am
here's
on
the
that
thing.
committee.
So if we assemble the best committee that we can for that standard, and these are the things that are talked about and put into the standard, then that is our guideline, because it is based in industry knowledge, best practices, and professionals that deal with this all the time. Okay, so that's the softball there. It depends. Okay, if I had to pick, I mean, as an industrial hygienist, we'd find that out anyways, but perhaps I would have gone to that standard first and taken a look, right? Because I don't know what's in it. I haven't read it, but I can tell you that you guys probably spent a lot of time on it and a lot of discussion about whys and wherefores. Same with the silica standard. I think that there has been a lot of discussion behind the silica standard. You know, do I think it's a perfect standard? I would say no, but it is workable, right?
So
And it's nothing to be afraid of.
Let's talk about that silica standard for a second, because it's what I wanted to bring up. And I didn't mean to cut you off. Before we get too far in, let me kind of preface this. You know, the silica standard got revised in what, 2014, 2015, right?
About then, yeah.
And it lowered the permissible exposure limit to 50 micrograms per cubic meter of air. And I used to do an exercise where I converted that to like grams and milligrams and all the way down to that. Math, right? So if we wanted to take a microgram, 50 micrograms per cubic meter of air, and give you a visual, 1,000 micrograms, right, is about 8 grains of sugar. I can't even see 50 micrograms per cubic meter of air with the naked eye. Now, why is this important for our workers? Because when we start talking about inhaling silica dust, whether it's in frac situations in oil and gas industry, or in concrete and masonry, and construction, and all these other industries, we're talking about something that has basically the same effect as asbestosis and mesothelioma. And we've known about silica and the hazards of silica back to the Roosevelt days. I'm talking about Teddy.
I have a whole presentation on silica that I give for silica awareness, and way back, and I believe it's Frances Perkins, the female that was in charge of, she put out a video on silica and silicosis way back when. I actually have it in the presentation, because this has been a problem. It wasn't a problem in the 2000s, right? It was in the 20s, right? Now, when we talk about something that you can't see, but then monitoring for it and protecting from it, here's the kicker, right? And it's the same as the H2S standard. You get a bunch of people in the room, and they know scientifically that worker is not just going to sit there and inhale 50 milligrams per cubic liter of silica. They are going to be doing that job or task longer, and the cumulative effect of that is going to be an issue. Nobody's just going to go whack, whack, whack with a hammer and be done, right? Maybe,
right.
But in protection of the worker, we have to protect for the acute exposure and the chronic exposure.
And I find it interesting that the same companies that would never, you ask people how much asbestos do you want in your lungs, they're like, none, 0 asbestos in my lung. But the public relations campaign and information campaign for asbestos has been a lot more prevalent than the one for silica and silicosis. And so the same companies that are, hey, I don't want any asbestos around my workers, often routinely expose workers to silica. So how do I go about monitoring for silica and silica exposure? I mean, we can't get a silica exposure app, can we?
No. But there are tables, right? There are tables that you can follow that are pretty simple. And then there are contingencies for when you need to get out cyclones and meters that can be set up and monitor perimeter and or acute exposure within the work zone, right? Generally, that's something I've seen people hire me for as an industrial hygienist, but it can be done by a practitioner with some guidance. Okay, none of this is rocket science, especially when some of the silica collection devices. It's not rocket science or rocket surgery, as one of my friends likes to say. But you may have to spend a couple hours with a industrial hygiene lab or with a certified industrial hygienist and have them talk you through it. It should not be a scary thing. Okay, it can be done, but you can also follow the guidance within the regulations, and you can also go to some of those websites that we talked about before, CPWR. For construction industry, they have a lot of good material. A lot of the state sites have good material. There are fact sheets out there to follow. OSHA has some guidance documents. So use your tools in order to prepare yourself. And then, and this is very important, know your limits. Being scared is not a limit. Okay. Being scared is, I need more information.
Right.
Most often, right? And this is coming from somebody who is scared and thinks it's a limit oftentimes, right? I will say that about myself. But being scared is not a limit. Being scared is not knowing what you don't know, right? So go and get the information. And if you still are tentative about an industrial hygiene problem, then call an industrial hygienist and get some help, or phone a friend. I mean, James, you have done industrial hygiene calculations. I'm sure of it. It doesn't make you a certified industrial hygienist because you got to take the test, but it makes you a trusted colleague, right?
Well, it lets me know when we have a problem and I need to call for support. And speaking of support, and we're going to talk about some other areas of industrial hygiene that freak out safety professionals that are general practitioners, right? But in my experience, sometimes in your workers' comp policies, there'll be coverage, and actually your workers' comp carrier will actually help pay for some basic industrial hygiene services that help lead to the prevention of injuries. Because once we get worker exposure and then we get worker illness or we get worker injury, we got a workers' comp claim. So they see that sort of as a proactive measure to prevent worker injury and illness in the workplace. So go check with your workers' comp carrier and see if they can help pay for that.
And you know what? I actually that is a tremendous tip for people listening to this. A lot of people think insurance carriers just come to walk around, loss control specialists just come to walk around your site, right? But if you really have a concern, there are carriers that have their own industrial hygiene labs. I'm not going to plug anybody, but they do have their own industrial hygiene labs, and they send people out. Same thing with basic insurance carriers, at least here in New England. They have an industrial hygiene specialist, and they send them out, and they actually do sampling for their clients. So, if you don't know, then ask, because you may be missing out on some valuable resources that they can provide that you don't have to pay for, that you're paying for within your premium.
Here's another area. I've got two more areas I want to talk about before we get out of here today. Asbestos is one, and then we have, asbestos awareness, and then we have asbestos abatement and removal. And certainly the people that are removing asbestos certainly have to be more cognizant of the hazards, respiratory protection, all the elements of the standard. But that's probably a greater discussion for another episode, that we could talk about what all the things they need to actually remove asbestos. But let's talk about the general worker, the worker that may be working, let's say, in a facility that may have asbestos tiles, for example. What kind of exposures do you typically see to workers potentially that are in facilities that have asbestos? Like, where can they find it? What do they need to be worried about?
Well, first of all, the employer needs to be aware, in aged facilities, of where these locations are: tiles, pipe wrapping, ceiling tiles, wall plasters, things of that nature, right? So that's part of the awareness. And that should always be provided to the worker as part of their orientation, right? If you see this, see something, say something, right? And don't touch it, because that really is, and leave the area. You know, in a lot of older facilities, I will say I've worked with a lot of schools, older schools. They have asbestos in a lot of places that that you wouldn't think of. They actually have professionals on staff that deal with asbestos, right? They have the asbestos removal technicians, they have project supervisors, they have all of those kind of activities. As an industrial hygienist, unless they have qualifications in that area, it's not something that I would use a specific industrial hygienist for, unless they did have that experience. But for the general worker, company has an obligation to tell them what those things are, and to have a see something, say something, in some kind of a response plan of how they're going to handle it.
You know, where in the episode that aired last week before this one, we talked about a lot about disaster preparedness. And this is where I had my first real exposure with asbestos. Asbestos tiles, asbestos siding, busted apart, broken in houses that have been destroyed, and then we get to cleanup, right? Mm-hmm. And so you have to be very careful when you're out there doing cleanup operations of houses that have been destroyed or significantly damaged during those weather events, because that's a chance for that asbestos to break up and get to be friable, right? Mm-hmm. And airborne, and then we can inhale it. So for those mm-hmm. type of workers, you're going to need special training. For the general worker, just being aware that there's a hazard, how to recognize when we have a potential for exposure, who to alert, is probably sufficient. Do you agree?
I agree. And here's for another program. I know we're generating a lot of ideas, but I've been involved in a lot of facilities that have done retrofits or new construction projects, and they not only deal with asbestos, but they deal with PCBs in building caulk, in paint, in lead paint. So, you know, when you start talking about building waste, especially in natural disasters or in demolition projects, all of that stuff needs to be removed or becomes commingled waste, and it has to all be disposed of at a very high cost, right? So being aware of what you have before you get into a situation where you have to deal with it is super important. So
you mentioned lead. We're kind of running out of time, and I want to get to one that's pretty hot. But here's my rule on lead. Don't even look at lead. Don't look at lead. Lead is bad. Stay away from lead. That's my policy. I'm anti-lead, right? So, yeah. But lead is a concern, and it generates very complicated medical surveillance program, probably one that I think is the most intrusive, because we're talking about blood in, blood out for exposures when we have workers exposed to lead. So a lead exposure control program is very complicated, and you probably want to have definitely the advice of a certified industrial hygienist when you're implementing those programs. But the last one I want to get to is more general.
All right.
And it is the voodoo science, that was a Dr. Martin word, the voodoo science of ergonomics.
Oh, man, you called my ass out. Oh, excuse me. Oh, man, you called me out. Yeah, I mean, listen, we've had OSHA try to put a standard through on ergonomics. I have a very, very, very deep opinion on ergonomics. I think it just, you're gonna love this, it just depends, right? It just
depends.
Because all of us are different. You know, I get the idea of you know, an average this and an average that, but in general, the US population, the world population none of us are average. We all have different ailments. We all have different body mechanics. We've learned how to operate our bodies in different ways. And so when you're looking at an ergonomics program, you can go general, but if you're looking at a specific person, you really have to dive deep into, you know, what that task is doing to their body. And you know, just for the people who are going to get really mad about this, I call it a voodoo science because, you know, I don't think you can be general. about anything that goes into your
Right.
body or you do to your body, because we are all so different. I wouldn't want to be an ergonomic person just for that nature. It is, if you do it right, and you are intensely focused on the specific workers that you're trying to help, then you are going to spend a lot of time, and modifications are going to be expensive.
I mean, I think both of us agree, and certainly I didn't mean to put you on the spot. I thought it was pretty
Thanks for
funny.
that.
I think it's pretty
Thanks for
funny.
that.
But we both agree that musculoskeletal disorders in the workplace are a real thing. They're a real thing. But
Mhm.
and I think you can based on my research and ergonomics and some of the studies I've read and some of the training I've received, we're trying to engineer for the vast majority of the percentile, right? The
Mhm. It's
percentile
a
of
start.
people.
That's a
It's a
start.
start. But where the general practitioner, I think, needs help is understanding what you just said. It's about the individual. Oh, I bought them ergonomic chairs for the work from home environment. Well, if that chair doesn't match that individual, right? And that individual's needs, is it preventing, all the things are related to WMSDs in the
Right.
workplace? Probably not. Maybe actually doing more harm than good. So for a general practitioner, ergonomics for me means looking at the individual and trying to design the work to the individual, not the individual to the work.
100%. 100%. Right. If you can engineer out the hazard, for all workers, I mean, like, here's a good example. Tables that go up and down for shipping, right? And they can be adjusted for each worker that comes up or down, in order for them not to bend or twist or those types of things. That's a really good engineering control, right? Because it can be adjusted. It is built for the general population, but it can be adjusted for the worker in the moment or in the shift that they work, which is terrific, right? Um, you know, I hate to say this, but for OSHA or anybody to cite that an ergonomics issue is valid, or even accept, because I've heard a lot of people say, well, it just kind of falls under the general duty cause. Well, yeah, kind of, but how many of those have you seen cited under the general duty cause for real, right? For real. So ergonomics becomes a labor of love for your employees, right? It becomes a labor of figuring out specific problems. And I had a dissertation student that used sensors to look at different tasks and to find out where the pain points were, for employees, and to change how they mechanically did their labor intensive jobs, their manual jobs. Terrific, right? But there still is a piece of that when another worker comes along, they either need to be trained in the same aspects, or you need to look at them and see if they're doing things physically the same way.
Where
Now,
I
I hope we get a lot of comments on this, because I'm not an ergonomics expert, but I sure have a lot of opinions on it.
me as well. I'm definitely not an ergonomics expert, and this kind of where I'm going. Where I routinely run into ergonomics is in manual lifting. And I'm not going to get into the NIOSH lifting equation that's this long, right? That some brain wrote, and it may work, but James ain't got time to figure all that out, right? I can't carry a calculator with me to the job site.
They have an app for that.
They have an app for that. Well, tell us about the NIOSH lifting equation. And
Well, listen, I'm not an ergonomics expert, but I will say that there's an app for just about everything. The NIOSH lifting equation, I believe, has an app or two on the Apple Store or the Android store. Check it out. I think some of those are old. They're definitely imperfect. Um, in my estimation, I don't see a lot of people using those. I think technology is the answer in this case. For example, this dissertation student that used the sensor based readout, and could really look at range of motion and where people were putting things. I think technology is more the answer here for ergonomics than it is some random, and okay, it's not random, but some lifting equation that's been around for a long time that, but quite frankly, nobody uses and nobody understands.
I tend to agree with that, and this is why I want to come back to this. I don't want to suggest or come across suggest that Dr. Martin and I don't think ergonomics is important, but it's very complex.
It's important.
It's extremely important when you start looking at the frequency of injuries, the type of injuries that we see on the job site to workers. There's a lot of sprains, strains, things of that nature, both acute and chronic injuries. So you need to have an ergonomics program, but it also needs to be one that's not so generalized that it applies to everything and effectively it does nothing. It does nothing.
Right.
Right.
Right. It has to be an active program. It has to be an active program.
Right. Absolutely. I wrote an article back during COVID. I was doing a lot of work at home. My first real work from home environment. I wasn't set up for it, sitting at the kitchen table, typing, doing these projects and things. Man, I got up one day, my back was killing me, just killing me. And I went out to our driveway and I was walking up and down trying to stretch my back out and stuff. And I thought about, hey, COVID-19 and ergonomics. And really what that could be labeled today is working from home and ergonomics. Now that we've transitioned the workplace from a beautiful facility like you have behind you to people's kitchen tables, sofas, you know, how much strain are we putting on workers from an ergonomic standpoint? And then that really comes down to customizing that person's workstation at their house, something that people really haven't thought about. But it's not simply going down to the store and buying someone an ergonomic chair. You know, their desk is fitting this to the person. But anyway, Dr. Martin, thank you for your insights on industrial hygiene. It's demystified.
I have a lot of opinions, James.
You do. And I do as well. But, you know, I think when we start talking about industrial hygiene, hopefully this episode has given general practitioners and safety places to go to for resources and understand it's not always that big, scary math problem over there. That really what we got to do is figure out what workers' exposures are, what the hazards are, what the potential for exposure is, what the risk, and what controls we need to put in place.
And as Mr. Rogers says, look for the helpers.
Look for the helpers.
So thanks again for listening to the Risk Matrix with James Junkin.
Roll Tide, baby.
And myself, Dr. Martin. We'll see you next time and have a great day.
Before you leave us, go down there, hit that like button, hit subscribe, hit us up in the comment section, follow us on LinkedIn, and do what you can to get those workers home safe.